வெல்கம் டு S3 ப்ரோக்ராமிங் டெக் சேனல். இன்னைக்கு நம்ம பார்க்க போற டாபிக் என்ன அப்படின்னு பாத்தீங்கன்னா, ரொம்பவே இம்பார்ட்டன்டான டாபிக் மெஷின் லேர்னிங். ஸோ இப்போ எல்லா ப்ராஜெக்ட்டுமே வந்து மெஷின் லேர்னிங் தான் பண்றோம். சம் ஸ்டாட்டிஸ்டிக்கல் அண்ட் கிரிட்டிக்கல் ப்ராப்ளம்ஸ் எல்லாமே வந்து நம்ம மெஷின் லேர்னிங்ல தான் பண்ணிட்டு இருக்கோம். ஸோ மெஷின் லேர்னிங்னா என்ன, அதோட அல்காரிதம்ஸ் என்ன, அதோட டெக்னிக்ஸ் என்ன அப்படின்னு தெரிஞ்சுட்டு நம்ம வந்து டேட்டா சயின்ஸ்ல எப்படி அனலைஸ் பண்றது அப்படிங்கறத நான் இனிமே சொல்லி தர போறேன். ஸோ இப்ப ஃபர்ஸ்ட் வந்து மெஷின் லேர்னிங்னா என்ன, அதுல என்னென்னலாம் இருக்கு அப்படிங்கறத நம்ம தெரிஞ்சுக்கணும். ஸோ இதை வந்து நான் வந்து ஒரு பவர் பாயிண்ட் பிரசன்டேஷனா வந்து ரெடி பண்ணிருக்கேன். ஸோ நம்ம வாங்க வீடியோக்குள்ள போலாம். Introduction to machine learning. So what is the machine learning? In the real world, we are surrounded by humans who can learn everything from their experience with the learning capability. And we have computers or machines which work on our instructions. But can a machine also learn from experience or past data like a human does? So here comes the role of machine learning. Machine learning is set as a subset of artificial intelligence that is mainly concerned with development of algorithms which allows a computer to learn from the data and past experience and the board. The term machine learning was first introduced by Arthur Samuel in 1959. With the help of the sample historical data, which is known as a training data, the machine learning algorithms build a mathematical model that helps in making prediction or decision without being explicitly programmed. The machine learning brings computer science and statistics together for creating predictive models. The machine learning construct or use the algorithms that learn from historical data. The more we will provide the information, the higher will be the performance. So next என்னன்னு பாத்தீங்கன்னா, history of the machine learning. Before some years, about 40 to 50 years, the machine learning was science fiction, but today it is a part of our daily life. The machine learning is making our day-to-day life easy, from self-driving cars to Amazon virtual assistant, Alexa. However, the idea behind the machine learning is so old and has a long history. So what is the history? The early history of machine learning, 1940, 1834. In 1834, Charles Babbage, the father of the computer, already we know, conceived a device that could be programmed with punch cards. However, the machine was never built, but all the modern computers rely on its logical structure. In 1936, Alan Turing have a theory that how a machine can determine and execute a set of instructions. Next one, the era of the stored program computers. In 1940, the first manually operated computer, ENIAC, was invented, which was the first electronic general purpose computer. After that, stored the program computer, such as EDSAC in 1949 and EDBAC in 1951 were invented. In 1943, a human neural network was modeled with an electrical circuit. In 1950, the scientists started applying their idea to work and analyzed how human numerals might work. Next one, the computer machinery and intelligence. In 1950, Alan Turing published a seminar paper, Computer Machinery and Intelligence, on the topic of artificial intelligence and machine intelligence in games. In 1952, Arthur Samuel, who was the pioneer of machine learning, created a program that helped an IBM computer to play a checkers game. It performed better more it played. In 1959, the term machine learning was first coined by Arthur Samuel. In 1959, the first neural network was applied to real-world problems to remove the echoes over phone lines using the adaptive filter. In 1985, the Charles Rosenberg invented a neural network, NetTalk, which was able to teach itself how to correctly pronounce 20,000 words in 1 week. In 1997, the IBM Deep Blue intelligent computer won the chess game against the chess expert Gary, and it became the first computer which had beaten a human chess expert. In 21st century, in the machine learning, in 2006, computer scientist Geoffrey Hinton has given a new name to neural net research as a deep learning, and nowadays it has become one of the most trending technologies. In 2012, Google created a deep neural network which is learned to recognize the image of humans and cats in YouTube videos. In 2014, the chatbot Eugen Goodsman cleared that during test. It was the first chatbot who convinced 33% of human judges that it was not a machine. And 2014 invented a deep face, uh, was a deep neural network created by Facebook. And 2016 AlphaGo beat the world's number second player Lee Sedol at Go game. In 2017 is beat number one player of this game GG. And 2017 the team built an intelligent system that was able to learn the online trolling. So at present the machine learning great advertisement in its research, and it is represent everywhere around us, such as a self-driving cars, Amazon Alexa, chatbots, recommended systems, and many of more. It included supervisor, unsupervised, and reinforcement learning with clustering, classification, decision tree, and SVM algorithm, etc. So modern machine learning models can be used for making various predictions, including weather prediction, disease prediction, stock market analysis, etc. So this one is a difference in ML and traditional programming. So traditional programming, we feed in data, that is a input, plus program, that is a logic, run into the machine and get into the output. But machine learning, we feed in data, input, plus output, and run into the machine during the training, and the machine creates its own program, that is a logic, which can be evaluated while testing. That is your machine learning difference between the traditional programming. What does exactly learning means for a computer? A computer is said to be learning from experience with respect to some classes of tasks. If it is performances in a given task improve with the experience. A computer program is said to learn from experience E with respect to some classes of task T and the performance measure P. If it is performance at task in T as measured by P, improve with experience E. So that is a exactly learning the computer. So example, playing checkers. E, the experience of playing many games of checkers. T, the task of playing checkers. P, the probability that the program will win the next game. Next, features of machine learning. So machine learning uses the data to detect the various patterns in the given data set. It can learn from past data and improve automatically. It is a data-driven technology. That is, machine learning is much similar to data mining as it also deals with the huge amount of the data for data analyzers. Next one, need for machine learning. The need for machine learning is increasing day by day. The reason behind the need for machine learning is that it is capable of doing tasks that are too complex for a person to implement directly. As a human, we have some limitation as we cannot access a huge amount of the data manually. So for this, we need some computer systems. And here comes the machine learning to make things easy for us. We can train machine learning algorithms by providing them the huge amount of the data and let them explore the data, construct the model, and predict the required output automatically. The performance of the machine learning algorithm depends on the amount of the data, and it can be determined by the cost functions. With the help of the machine learning, we can save both time and money. The importance of the machine learning can be easily understood by its use cases. Currently, the machine learning is used in self-driving cars, cyber fraud detection, face recognition, and friend suggestion by Facebook, etc. Various top companies such as Netflix and Amazon have built machine learning models that are using a vast amount of the data to analyze the user interest and recommended the product accordingly. So the following some key points which show the importance of the machine learning: rapid increment the production of the data, solving the complex problems which are difficult for a human, decision making in various sectors including finance, finding the hidden patterns and extracting useful information from the data. Next one, application of the machine learning. So the machine learning is a buzzword for today's technology, and it is growing very rapidly day by day. We are using machine learning in our daily life even without knowing it, such as a Google Map, Google Assistant, Alexa, etc. So, some most trending real world application of the machine learning: image recognition. So, image recognition is one of the most common application of the machine learning. It is used to identify the object, person, place, digital images, etc. The popular use cases of the image recognition and face detection is automatic friend tagging suggestions. The Facebook provides us a features of auto friend tagging suggestions. Whenever we upload a photo with our Facebook friends, then we automatically get a tagging suggestion with a name and the technology behind this machine learning face detection and recognition algorithm. It is based on the Facebook project named Dplyr, which is responsible for face recognition and person identification in the picture. Next one, speech recognition. While using the Google, we get the option of search by voice. It comes under the speech recognition, and it is a popular application of the machine learning. Speech recognition is a process of converting voice instruction into the text, and it is also known as a speech to text or computer speech recognition. At present, machine learning algorithms are widely used by various applications of speech recognition. Google Assistant, Siri, Cortana, and Alexa are using the speech recognition technology to follow the voice instruction. Next one, traffic prediction. A new place, we take help of Google Map, which shows us the correct path with the shortest route, and prediction the traffic condition. It predicts the traffic condition such as whether traffic is clear, slow moving, or heavily congested with the help of two ways. First one, real-time location of the vehicle from Google Map and sensor. Next one, average time has taken or past days at the same time. Everyone who is using Google Map is helping this app to make it better. It takes information from the user and sends back to its database to improve the performance. Next one, recommendation. The machine learning is widely used by various e-commerce and entertainment companies such as Amazon, Netflix, etc. for a product accommodation to the user. Whenever we search for some product on Amazon, then we started getting an advertisement for the some same product while internet surfing on the same browser, and this because of the machine learning. Google understand the user interest using various machine learning algorithms and suggest the product as per the customer interest. A similar, when we use the Netflix, we find some recommendation for the entertainment services, movies, etc. And this is also done with the help of machine learning. Next one, self-driving cars. One of the most exciting application of the machine learning is self-driving cars. Machine learning plays a significant role in self-driving cars. Tesla, the most popular car manufacturing company, is working on self-driving car. It is using unsupervised learning method to train the car models to detect the people and object while driving. Next one, email spam and malware filtering. Whenever we receive a new email, it is filtered automatically as important, normal, and spam. We always receive an important mail in our inbox with the important symbol and spam emails in our spam box, and the technology behind this machine learning. Here some spam filters used by Gmail: content filter, header filter, general blacklist filter, rules based filter, permission filter. Some machine learning algorithms such as a multi-layer perception decision tree and AV bias classifier are used to email spam filtering and malware detection. Next, virtual personal assistant. We have various virtual personal assistants such as a Google Assistant, Alexa, Cortana, Siri. As the name of subject, they help us in finding the information using our voice instructions. These assistants help us in various ways just by our voice instructions such as a play music, call someone, open a Gmail, scheduling an appointment, etc. These virtual assistants are machine learning algorithm as an important part. These assistants record our voice instruction, send it over the server on a cloud, and decode it using the ML algorithms and act accordingly. Next one, online fraud detection. Machine learning is making our online transactions safe and secure by detecting the fraud transactions. Whenever we perform some online transaction, there may be various ways that a fraudulent transaction can take place, such as a fake accounts, fake IDs, and steal money in the middle of the transactions. So to detect this, feed forward neural network helps us checking whether it is a genuine transaction or a fraud transaction. For each genuine transaction, the output is converted into some hash values, and these values became the input for the next round. For each genuine transaction, there is a specific pattern which gets a change for the fraud detections. Hence, it detects it and makes our online transaction more secure. Next one, stock market trading. Machine learning is widely used in stock market trading. In the stock market, there is always a risk of up and downs in charts. So, for this machine learning, long short term memory neural network is used for the prediction of stock market trends. Next one, automatic language translation. Nowadays, if we visit a new place and we are not aware of language, then it is not a problem at all. As for this, also the machine learning helps us by converting the text into our known languages. Google GNMT, Google Neural Machine Translation, provide this feature, which is a neural machine learning that translates the text into our familiar language, and it called the automatic translation. The technology behind the automatic translation is a sequence to sequence learning algorithm, which is used with the image recognition and translate the text from one language to another language. Next, we see the machine learning life cycle. Machine learning has given the computer system to the abilities automatically learn without being explicitly programmed. But how does a machine learning system work? So, it can be described using the life cycle of machine learning. Machine learning life cycle is a cyclic process to build an efficient machine learning project. The main purpose of the life cycle is to find the solution to the problem or project. Machine learning life cycle involves 7 major steps. First one, gathering the data. Data gathering is the first step of the machine learning life cycle. The goal of this step is to identify and obtain all data, that is a related problem data. In this step, we need to identify the different data sources, as data can be collected from various sources such as files, database, internet, or mobile devices. It is one of the most important steps of the life cycle. The quantity and quality of the collected data will determine the efficiency of the output. The more will be the data, the more accurate will be the prediction. The steps include the data collection, identify the various data sources, collect the data, integrate the data obtained from the different sources. By performing the above task, we get a coherent set of the data, also called as a data set. It will be used in the further steps. Next one, data preparation. After collecting the data, we need to prepare it for further steps. Data preparation is a step where we put our data into a suitable place and prepare it to use in our machine learning training. In this step, first we put all data together and then randomize the ordering of the data. This step can further divided into two processes: data exploration, data pre-processing. Data exploration, it is used to understand the nature of the data that we have to work with. We need to understand the characteristic, format and quality of the data. A better understanding of the data leads to the effective outcome. In this, we find correlation, general trends and outliers. And data pre-processing, now the next step is the pre-processing of the data for its analysis. Third one, data wrangling. Data wrangling is the process of cleaning and converting raw data into the usable format. So it is the process of cleaning the data, selecting the variable to use and transforming the data into proper format to make it more suitable for analysis in the next step. It is one of the most important steps of the complete process. Cleaning of data is required to address the quality issue. It is not necessary that data we have collected is always of our use, as some of the data may not be useful. In real world applications, collected data may have various issues including missing values, duplicating data, invalid data, noise. So we use various filtering techniques to clean the data. It is mandatory to detect and remove the above issues because it can negatively affect the quality of the outcome. And fourth one, data analysis. Now, the clean and prepared data is passed on the analysis step. This step involves selection of analytical techniques, building models, and review the result. The aim of this step is to build a machine learning model to analyze the data using the various analytical techniques and review the outcome. It starts with the determination of the type of problems where we select the machine learning techniques such as a classification, regression, cluster analysis, association, etc. Then build the model using prepared data and evaluate the model. Hence, in this step, we take the data and use machine learning algorithms to build the model. Fifth one, train model. Now, the next step is to train the model. In this step, we train our model to improve its performance for better outcome of the problem. We use dataset to train the model using various machine learning algorithms. Training a model is secured so that it can understand the various patterns, rules, and features. Next one, test model. Once our machine learning model has been trained on a given data set, then we test the model. In this step, we check for the accuracy of the model by providing a test data set to it. Testing the model determines the percentage accuracy of the model as per the requirement of the project or problem. And deployment. The last step of machine learning lifecycle is deployment, where we deploy the model in the real world system. If the above prepared model is producing an accurate result as per our requirement with acceptable speed, then we deploy the model in the real systems. But before deploying the project, we will check whether it is improving its performance using available data or not. The deployment phase is similar to making the final report for the project. Next one, classification of the machine learning. So, a broad level, the machine learning can have classified into three steps: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning. The supervised learning is a type of machine learning method in which we provide the sample labeled data to the machine learning system in order to train it and that basis it predicts the output. The system creates a model using the labeled data to understand the data set and learn about each data. Once the training and the processing are done, then we test the model by providing the sample data to check whether it is predicting the exact output or not. The goal of supervised learning is to map input data with output data. The supervised learning is based on the supervision, and it is the same as when a student learns things in the supervision of the teacher. The example of supervised learning is SAM filtering. Supervised learning can be grouped further into categories of algorithms, classification and regression, types, regression, logistic regression, classification, navy bias classifier, decision tree, and support vector machine. Next one, unsupervised learning. Unsupervised learning is a learning method in which a machine learns without any supervision. The training is provided to the machine with a set of the data that has not been labeled, classified, or categorized, and the algorithm needs to act on the data without any supervision. The goal of unsupervised learning is to restructure the input data into new features or a group of objects with similar patterns. In supervised learning, we don't have a predetermined result. The machine tries to find useful insight from the huge amount of the data. It can be further classified into two categories of the algorithm: clustering and association. Types: clustering exclusive, agglomerative, overlapping, probabilistic. Clustering, hierarchical clustering, and k-means clustering. Next one, KNN, K nearest neighbor clustering, principal component analysis, singular value decomposition, independent component analysis. The last one, reinforcement learning. Reinforcement learning is a feedback-based learning method in which a learning agent gets a reward for each right action and gets a penalty for each wrong action. The agent learns automatically with these feedback and improve its performance. In reinforcement learning, the agent interacts with the environment and explore it. The goal of an agent is to get the most reward points and hence it improve the performance. The robotic dog, which automatically learns the movement of his arms, is an example of the reinforcement learning. Some main points of the reinforcement learning: input. The input should be from the initial stage where the model actually starts. And output. There are the multiple outputs to any problem. Training. As the training is dependent on input, the model will return the state and the user will decide to reward or discard the model based on its output. Next, we can see the machine learning in R. The R language is basically developed by statistical environment. Now, we know that machine learning is basically working with a large amount of data, and statistics as part of the data science, and use of R language is always recommended. Therefore, the R language is mostly becoming handy for those working with the machine learning, making the task easier, faster, and innovative. So, how machine learning works? Clean the data obtained from the data set, select a proper algorithm for building the prediction model, train your model to understand the pattern of the project, predict your results with higher accuracy.
Advantages to implement the machine learning using the R language. It provides good explanatory code. For example, if you are at the early stage of working with a machine learning project and you need to explain the work you do, it becomes easy to work with R language comparison to Python, as it provides a proper statistical method to work with the data with fewer lines of the code. Next one, R language is perfect for data visualization. R language provides the best prototype to work with the machine learning model. Next one, R language has the best tools and library packages to work with the machine learning project. The developers can use these packages to create the best pre-model, model, and post-model for the machine learning project. Also, the packages for R are more advanced and extensive the Python language, which makes it the first choice to work with the machine learning project. Next one, popular R language packages used to implement the machine learning. Popular R language packages used to implement the machine learning. First one, lattice. The lattice package support the creation of the graphs displaying the variable relations between the multiple variables with conditions. Next one, data explorer. The R package focus to automate the data visualization and data handling so that the user can pay attention to data insights of the project. Next one, Daleks, descriptive machine learning explanations. This package helps us to provide the various explanation for the relation between the input variable and its output. It helps to understand the complex models of the machine learning. Next one, Dplyr. This R package is used to summarize the tabular data of the machine learning with rows and columns. It applies the split, apply, combine approach. Next one, Squeezes. This R package is used to explore the data quickly to get the information it holds. It also allows to plot bar graph, histogram, curves, and scatter plot. Next one, Correct. This R package attempts to streamline the process for creating the predictive models. Next one, Janitor. This R package has functions for examining and cleaning the dirty data. It is basically built for the purpose of user friendliness for beginners and intermediate user. Next one, R part. This R package helps to create the classification and regression models using two-stage procedures. The resulting models are represented as a binary trees. Next one, application of our R in machine learning. There are many top companies like Google, Facebook, Uber, etc. using the R language for application of machine learning. The application are social network analytics to analyze the trends and patterns, getting insights for behavior of user, to find the relationship between the user, developing the analytical solutions, accessing the charting components, embedding the interactive visual graphics. Next one, types of machine learning problems. So first one, regression. The regression techniques helps the machine learning approach to predict the continuous values. For example, the price of the house. Next one, classifications. The input is divided into one or more classes or categories for the learner to produce a model to assign the unseen models. For example, in the case of email fraud, we can divide the emails into two classes. Example, spam and not spam. Next one, clustering. This technique follows the summarizations, finding a group of similar entities. For example, we can gather and take readings of the patients in the hospital. Next one, association. The association technique finds co-occurring events or items. For example, market basket. Next one, anomaly detections. This technique works by discovering the abnormal cases or behavior. For example, the credit card fraud detection. Next one, sequence mining. The sequence mining technique predict the next steam event. For example, click steam event. Next one, recommendations. This technique recommend the item, for example, songs or movies according to the celebrity in it. Next one, example of machine learning problems. First one, web search like Siri, Alexa, Google, Cortana. Recognize the user voice and fulfill the request made. Social media services help people to connect all over the world and also show the recommendation of the people we may know. Next one, online customer support. It provides the high convenience of the customer and efficiency of the support agent. Next one, intelligent gaming. It uses the high level responsive and adaptive non-player characters similar to human like intelligence. Next one, product recommendation. A software tool used to recommend the product that you might like to purchase or engage with. Next one, virtual personal assistants. It is a software which can perform the task according to the instruction provided. Next one, traffic alerts. It helps to switch the traffic alerts according to the situation provided. Next one, online fraud detection. It checks the unusual functions performed by the user and detect the frauds. And next one, healthcare. The machine learning can manage a large amount of the data behind the imagination of normal human being and help to identify the illness of the pattern according to the symptoms. And the last one, real world example. When you search for some kind of the cooking recipe on the YouTube, you will see the recommendation below the title. You may also like this. This is a common use of the machine learning. Next one, data in machine learning. Data, it can be any unprocessed fact, value, text, sound, or picture that is not being interpreted or analyzed. Data is most important part of all data analytics, machine learning, artificial intelligence. Without data, we cannot train any model, and all modern research and automation will go in vain. Big enterprises are spending lots of money just to gather as much certain data as possible. Example, why did Facebook acquire the WhatsApp by paying the huge price of $19 million? The answer is very simple and logical. Is it to have access the user information that Facebook may not have, but WhatsApp will have. This information of the user is of paramount importance of the Facebook, as it will facilitate the task of improvement in the services. Next one, informations. Data that has been interpreted and manipulated and has now some meaningful inference for the user. Knowledge. The combination of the inferred informations, experience, learning, and insights. The results in awareness or concept building for the individual or organization. How we split data in the machine learning? It have the three type of the split: training data, validation data, and testing data. Training data, the part of the data we use to train our model. This is the data that your model actually sees both input and output and learns from. Validation data, the part of the data that is used to do a frequent evaluation of the model fit on the training data set along with improving involved hyperparameters. Initially, set parameters before the model begins learning. This data plays its part when the model is actually training. Next one, testing data. Once our model is completely trained, testing data provides an unbiased evaluations. When we feed in the input of testing data, our model will predict some values without seeing actual output. After predictions, we evaluate our model by comparing it with the actual output present in the testing data. This is how we evaluate and see how much our model has learned from the experience feed is our training data set at the time of training. Some properties of the data: volume, the scale of the data. With the growing world population and technology exposure, huge data is being generated each and every millisecond. Variety, different forms of the data: healthcare, images, videos, audio, clippings, etc. Next one, velocity. The rate of the data streaming and generation, and value, meaningfulness of data. In terms of information, the researchers can infer from veracity, certainty, and correctness in data we are working on. Next one, how to understanding the data processing. Data processing means it's the task of converting data from the given form to a much more usable and desired form. Example, making it more meaningful and informative. Using the machine learning algorithms, mathematical modeling, and statistical knowledge, this entire process can be automated. The output of this complete process can be in any desired from like graphs, videos, charts, tables, images, and many more, depending on the task we are performing and the requirement of the machine. This might seem to be simple, but when it comes to massive organizations like Twitter, Facebook, administrative bodies like Parliament, UNESCO, and health sector organizations, this entire process needs to be performed in very structured manner. So the steps to perform as follows: collection, preparation. First one, collection. The most crucial step in starting the ML is to have a data of good quality and accuracy. Data can be collected from any authenticated source like data.government.in, Kogel, or UCA dataset repositories. For example, while preparing for competitive examination, students study from the best study material that they can access so that they learn the best to obtain the best results. In the same way, the high quality and accurate data will make the learning process of the model easier and better, and at the time of testing the model would yield the state of the art results. A huge amount of the capital, time, and resources are consumed in collecting data. Organization or researchers have to decide what kind of the data they need to execute the task or research. Example, working on the facial expression recognizer need numerous images having the variety of the human expressions. Good data ensure that the results of the model are valid and can be trusted on. Next one, preparations. The collected data can be in a raw form which cannot be directly fed to the machine. So this is a process of collecting data set from the different sources, analyzing these data set, and then constructing a new data set for further processing and exploration. This preparation can be performed either manually or from the automatic approach. Data can also be prepared in numeric forms, also which would fasten the model learning. Example, an image can be converted to the matrix of n into n dimension. The value of each cell will indicate the image pixel. Next one, input. Now the prepared data can be in the form that may not be machine readable. So the convert this data to the readable form. Some conversion algorithms are needed for this task to be executed. High computation and accuracy is needed. Example, the data can be collected through the sources like MNIST, digit data images, Twitter comments, audio files, video clips, etc. Next one, processing. This is a stage where algorithms and machine learning techniques are required to perform the instruction provided over the large volume of the data with accuracy and optimal computation. Next one, output. In this stage, the results are procured by the machines in a meaningful manner, which can be inferred easily by the user. Output can be in the form of reports, graphs, videos, etc. And the last one is a storage. This is the final step in which the obtain output and the data model, data and all the useful information are saved for future use. So we can understanding the data processing is important. Next one, overview of the data cleaning. Data cleaning is one of the important part of the machine learning. It plays a significant part in building a model. It surely is in the funniest part of the machine learning. At the same time, there aren't any hidden tricks or secrets to uncover. However, the success or failure of the project release and proper data cleaning. Professional data scientists usually invest a very large portion of the time in this step because the belief that better data beats fancy algorithm. If we have a well clean data set, there are changes that we can get achieve good results with a simple algorithm also, which can prove very beneficial at times, especially in terms of computation when the data set size is large. Obviously, different types of data will require different types of cleaning. However, this systematic approach can always serve as good starting point. The four steps involved in the data cleaning. First one, removal of unwanted observation. It includes deleting duplicate, redundant or irrelevant values from your data set. The duplicate observation most frequently arise during the data collection, and irrelevant observation are those that don't actually fit the specific problem that you are trying to solve. The redundant observation alter the efficiency by the great extent as the data. That is, data repeats and may add towards the correct side or towards the incorrect side, thereby the producing the unfaithful results. Irrelevant observation or any type of the data that is of no use to us and can removed directly. Next one, fixing structural errors. These errors that arise during the measurement, transfer the data, or other similar situation also are called structural errors. The structural errors include types in the name of the features, the same attribute with a different name, mislabeled classes. Example, the separate classes that should really be the same are inconsistent. Next one, fixing structural errors. The errors that arise during the measurement, transfer the data, or other similar situation are called structural errors. The structural errors include the types in the name of features, the same attribute with a different name, mislabeled classes. Example, the separate classes that should really be the same are inconsistent capitalization. For example, the model will treat America and America as different classes or values, though they represent the same value or red yellow as different classes or attributes. One classes can be included in other two classes. So these are some structural errors that make our model inefficient and give the poor quality results. Next one, managing the unwanted outliers. The outliers can cause the problems with the certain types of the models. For example, the linear regression models are less robust to outliers the decision tree models. Generally, we should not remove the outliers until we have a legitimate reason to remove them. Sometimes removing the improve the performance, sometimes not. So one must have a good reason to remove the outlier, such as a suspicious measurement that are unlikely to be part of the real data. And the fourth one, handling the missing data. Missing data is a tricky issue in the machine learning. We cannot just ignore or remove the missing observations. They must be handled carefully as they can be an index of something important. The two most common ways to deal with the missing data are: first one, dropping observation with the missing values. The fact that the value was missing may be informative in itself. Plus, in the real world, you often need to make prediction on new data even if some of the features are missing. And second one, inputting the missing value from the past observations. And second one, inputting the missing values from the past observations. Again, missingness is almost always informative in itself, and you can should tell your algorithm if a value was missing. Even if you build a model to impute your values, you are not adding any real informations. You are just reinforcing the patterns already provided by other features. So the missing data is like missing a puzzle piece. If you drop it, that's like presenting the puzzle slot is in the. If you input is that like trying to squeeze is a piece from somewhere else in the puzzle. So missing data is always an informative and an indication of something important, and we must be aware of algorithm of missing data by flagging it. By using this technique of flagging and filling, you are essentially allowing the algorithm to estimate the optimal consistency for missingness instead of just filling uh, in with the mean. Some data cleaning tools: Open Refine, Trifecta Wrangler, TIBCO Clarity, Cloud Ingo, IBM Enforce per Quality Stage. So thank you. If any questions, um, you can say the comment. We will meet next video. Thank you.